Okay, so the recording has begun. This is day 1, week 6 of our journey together. Anyone can remember the topic that we are on? The grand topic that we are on. No one can remember. Or I need to ask someone in particular. Sierra, help us out. The topic we are on in math.
Okay, we are on sample events probability.
Probability, very good. Uh-huh. Deja, what do we mean by sample space?
The sample space displays the outcomes or how likely something is going to happen.
How like
Basically, an element in the sample space.
so the sample space tells us all
Possible outcomes
possible outcomes, very
of
good.
an experiment.
Of an experiment, very good. Okay, that's excellent. What do we mean by an experiment, Dylan? In an experiment, do we know what is gonna happen before it happens? Or we don't, Dylan?
You repeat one more time, please?
In an experiment, do we know what is gonna happen before it happens? Yes or no? Or you don't know, or you can't remember.
I just can't remember at the
Can't remember.
moment.
Okay. That's open question then. In an experiment, do we know what is gonna happen before it occurs?
No.
No, we don't
Mm,
know. We don't know. Alright? If we know what's gonna happen, then it cannot be an experiment. Alright? Alright, so we're looking at sample spaces and events. This is part 4 of our journey. Last time we looked at the complement. Today we're going to be looking at the intersection of, alright, so let's take this down for me. So we're going to be looking at the intersection and the union of two events. Alright, so let's look at that. It should be pretty easy. We're going to try to break it down pretty nice for you all. Alright, and if you have any questions, let me know. Alright, so let's take this down. So we're going to do white fill and background. Let me use red. And let's stick in the outline some more. All right. So the topic that we're going to be looking at today, like I said, is we're going to be looking at the intersection and the union. So let's begin. So intersection of events. Intersection of events. Someone send a message. Hey, hello, Miss. Hello, Miss C. How you doing? Good to have you out today. It's been a while, man. So, intersection of events. All right. So intersection of events is similar to intersection of sets. If you ever did sets before with intersection, it's the same thing. It's basically the same idea. So let's write it down. So the intersection of the events E and F is the set of all, let me bring that down, is a set of all outcomes. And the keyword here is common. Common, so that's the keyword. Common common to E and F. So when we're looking at the intersection of events, we're looking at, okay, what events, sorry, what, if we look at these two events, what outcomes do they have in common? And that's going to be the intersection between them two. Right, so the intersection of events E and F is the set of all outcomes common to E and F. All right. Thus, E intersect, now the notation that we use for intersection is interesting. It's an upside down U. All right, so let me show you what I mean. So we have E intersect. So intersection is going to look like this. So E intersect F. All right. So thus E intersect F represents, so it's going to represent the event that both, so there's another keyword, both and common, both, right? Both E and F occur. All right, so both E and F occur. All right, so that's basically the definition for the intersection of events. And so we're going to break that down some more for you so we can understand what it is. But anyone have ever done intersection before? Just so that I can know if you are familiar with
Yes,
intersection.
sir.
Okay. Anyone else ever done intersection before? Intersection of sets? No, no one else? All right. So that means we have a lot of explaining to do today. So the intersection of events E and F is the set of all outcomes common to E and F. We don't need this underlined. Thus E intersect F, that is the notation for it, represents the event that both E and F occur. Okay. Okay, so let's look at some examples. I think we can do well to learn from these examples. So let's look at it. So please take this down. Remember, right after class, I want you to send me the notes. So please take it down for me, please. And right after class, I want you to send me a photo of your notes. All right, so examples. So let's say that we have the experiment. This is a familiar experiment that all of us, well, that we have been doing for a while now, but it does the trick. So the experiment is that you wanna roll a fair dice. So roll a fair dice and observe the numbers facing up. Okay, so we want to roll a fair dice and then we want to observe the numbers facing up. That's the experiment that we're looking at. Now, if we look carefully at a dice, let's look at a simple image, right? So if we look at a dice, so a dice is something like this. Notice carefully that a dice has 6 sides. So if you look for a dice, we have the side has 1, 2, 3, 4, 5, 6. So the side has 6. This one has 1, 2, 3, 4. This one has 4. This one has 1, 2, 3, 4, 5. This one has 5. Underneath has a certain number. on the other side has another number. So look carefully at the dice so we can understand what's happening. This is a good image. So this is showing the sides of a dice: 1, 2, 3, 4, 5, and 6. So a dice, or typical dice, has 6 sides. All right. This is another image showing you this: 1, 3, 5, 4, 2, and so on. So a dice has 6 sides. So if you roll a dice, you can either get 1, 2, 3, 4, 5, or 6. And so let's go back to our notes. So, sorry. So for the experiment is you roll in a fair dice. That's what the experiment is. And let's say that, let me just keep it bold. And let's say that our first event is, so event E is that,
Excuse me, Mr. Petit.
go ahead.
You can minimize this slide for me, please, because I'm trying to get the rest of those. I didn't get it
From the top?
before this example. Yes,
Okay,
sir.
sure. Let me do that. Okay, so maybe that helps. Maybe I could decrease
Yes,
this.
sir. That helps. Thanks.
Okay, no
Thank you.
problem. Yeah, no problem. All right. So event E, let's say that event E is that you want to um you want to let's say that the event E is that you observe an even number. Okay, so that's your event E. That's what you get. That's an event that you want to happen. That's the favorable outcomes. So with this event E, so we're gonna put on this side, so it's gonna be E. Now my question is, Sierra, what goes in E? What numbers? What numbers goes in E?
2, 4, 6.
2, 4, 2,
6.
4, and 6. All right. All right, good. So event E is that we observe an even number. And let's say that we have another event. So let's call it event F. Okay. Now event F is that I really think we should do the sample space before we do all that. So let's do the sample space. If we don't do the sample space, then it won't be complete. So the sample space is going to be all of the numbers that are on a dice. So the sample space is going to be help me out, Miss Johnson. What's going to be the sample space? Taisha Johnson. What's going to be in my sample space?
1, 2, 3, 4, 5, and 6.
Very good. 1, 2, 3, 4, 5, and 6. Good. Because there are 6 sides of a dice, and it could either land on 1, 2, 3, 4, 5, or 6. And if we get an even number, then the only even numbers here are going to be 2, 4, and 6. Now let's say the event F is that we observe a number greater than 1. Okay, that's our event F. We observe a number greater than 1. So Catlin, can you tell me what you think is going to be in event F? What numbers are going to be in event F? I can barely hear you. Say it again. She says, I'm not sure. Okay. Think about it. What numbers are greater than 1? From S, what numbers are greater than 1?
2,
Say
3,
two.
4, 5, and 6.
Very good, Rashan. So 2, 3, 4, 5, and 6. Good. So now we want, so we have event E and we have event F. Now we want the intersection of event E and event F. So we basically want an even number that's greater than 1, right? That's essentially what we want. So an even number that's greater than 1. So, okay, so the symbol that we're going to use for the intersection is E intersect F. All right, so E intersect F. So if we look at this set and we look at this set, right? Which numbers are common? So we're looking at this set and we're looking at this set. Okay, so let me ask Sienna. So think about it. If we look at set E and you look at set F, which numbers are common in both sets?
2, 4, and 6.
Very good. So 2 is common here, 4 is common, and 6 is common. So that's what we mean when we say the intersection. So the intersection is going to contain the numbers that are what? Common in both E and F. All right. We could kind of draw it, you know, if we, and I'll draw it right after this. So the numbers are 2, 4, and 6. So the intersection is going to be the intersection of these two events, event E and F, is going to be, like Sienna said, it's going to be 2, 4, and 6. All right, so that's the intersection. Any questions on how we got the intersection? And what did we do? Any questions on that? Don't be shy. Go ahead.
Yeah, so what you just say?
Yeah, any questions on how we got the intersection?
You see how we got the intersection?
So
If you have any questions on how on what we did or what we did. So let's visualize the intersection, right? So let's actually draw a visualization of it. Okay. So we know that on the outside we have a big box here. All right. We're gonna have 2 circles. And I think I should freehand them. So the first circle is as such. All right. Let's use a different background. Yeah, white is fine. So that's the first circle. Inside here, we're gonna call this one. We're gonna call this one E. Oh gee, you ain't allowing me to do that. All right. So let's draw the second circle. So the second circle is going to be. It's going to be F. Oh gee, that definitely don't look good. So let me do it again. So the second circle is going to be. Right. That's better. Good. So the first circle is what we call E. So that's my first circle now. And the second circle is going to contain F. All right. So what goes into my first circle, Deshaun? Into E. What goes into E?
2, 4, and 6.
Very good. 2. All my even numbers. So 2 and 4 and 6. And F is going to contain 2, 3, 4, 5, and 6. So we got to put this in the middle because the intersection is going to have 2 in it. Intersection is going to have 4 in it because that's in both of them. The intersection is going to have 6 in it as well. So the intersection has 2, 4, and 6 in it. Now, Deja, what's gonna be in F?
3,
3,
3 and 5.
3, and 5. Very good. Okay, so what is this saying? All right, this is saying that in the middle is all of the values that are the same in E and F. Okay, so this is what we call the intersection in the middle now. Call that the intersection. So this is what we call here the intersection.
Excuse me, how come E don't have no numbers in it?
E does. The only thing is that the numbers that are in E are also a part of F. So all of this circle is E. The whole thing is E. But it's just that all of the numbers that are the same in E are also in F as well. So that's why it looks like that E doesn't have anything. So this would be called the intersection. All right now. Intersection of events. Okay, that's what they have in common. All right. Okay, any questions on this before we go use another example?
No, so.
All right. Okay, sure enough. So let's move on. For the next one, we're going to use the same experiment and sample space. Because I think it's easy to use and it gets the idea quickly. So let's see. Sorry, let me scroll down. Okay, so let's say that the experiment that we have is that we are going to roll a fair dice, and observe the numbers facing up. Now, Jasmine, what will be a part of our sample space? Hello, Jasmine. What will be in our sample space? Okay, I can't hear from Jasmine. Go ahead, Rashan. What will be a part of our sample space?
1, 2, 3, 4, 5, 6.
Very good. 1, 2, 3, 4, 5, and 6, because those are the numbers that are on the dice. So we could either get a 1 when we roll it, a 2 when we roll it, a 3 when we roll it, a 4, a 5, or a 6 when we roll it. Okay, good. Now it's time for, let's say we have an event, and say that the event is, we're still gonna call the event E. And let's say that with this event, the event is that we observe an odd number. Okay, we observe an odd number. All right, so let's say that that's the case, and we call this event E. So, Miss Neely, are you there?
Yeah, so.
No, sorry, it's two Neelys I realized. Rainisha Neely, not Yurashan. Rainisha Neely, are you there?
Yes.
Okay, good. So we observe an odd number. So from this group of numbers, tell me what are the odd numbers?
Three, five.
3,
So
5,
what?
and 1.
5 and
Very,
1?
yeah, and 1. So 1, 3, and 5. Thank you, Miss C. Okay, good. So that's the event E. It is an odd number. We observe an odd number from this collection. So that's the first event. So let's say we have another event. Someone else. Let's say we have another event. And let's say that the event is that, you call it event F, capital F. And let's say that event is, I want to increase this because it's kind of annoying how small it is. So we observe a number greater than 4. Okay, so that is, no. Yeah, I think this is a good one. Observe a number greater than 4. So, no, let's say observe a number greater than 2. Let's say 2. I think 2 would be a good one. All right, so, Caitlin, what would be a part of this event F?
Three, 4, 5, 6.
Very good. 3, 4, 5, and 6. Excellent. Good. So now we want the intersection of E and F. So the intersection of E and F. So intersection of E and F is going to be what these two events have in common. All right? What these two events have in common, what numbers they have in common. So Albernic. Can you tell me what the intersection of these two events is going to be? What numbers are common in E and F?
Excuse me, what did you call?
Albernic.
Oh, the intersection is 3 and 5.
3 and 5. Very good. So the numbers that are common in these two events are going to be 3 and 5. Okay. So 3 is common in E and F, and also 5 is common in E and F. So that means that E intersect F is going to be, we have to put the curly brackets, and the curly brackets there, and it's going to be 3, comma, 5. Okay. All right. Now, let's visualize the intersection again. Okay, so let's go ahead and visualize intersection and see what we have. Okay, so visualizing the intersection again. So let's increase the size of this. All right, so we are going to draw how much circles?
2.
2, very good. So the first one, we're going to call that event E. And the second one, we're going to call that event F. So this is E. Sorry. And the next one is F. Okay. All right, I'm going to give you opportunity to fill that out yourself. What goes in E and F and what goes in intersection. So try that out on your own. Try it first, and then we could discuss it on the other side. So let's try it. So in E, we know that E is going to be the event that has odd numbers. So in E, we most definitely is going to have 1 in there. So we have 1 over there. In the intersection, what numbers are we going to have? 3 and 5. Yes. And so we have 3 and 5, and then in F, remember, these are the numbers that are greater than 2. So 3, 4 is gonna be here. What else is gonna be in L? What else is gonna be in L?
6.
6. Very good. Six. Very good. Good. So 1, 3, 5, and 6. So the intersection is going to have only 3 and 5 inside of it. Okay. So this is what we call the intersection of events. All right, so that's that. So that's what we mean by intersection of events. With the intersection of the events, we're looking for those numbers or outcomes that the sets or the events have in common. All right, and that's what we say the intersection of events is all about. Now we're gonna look at the union of events. The union of events. So let's consider that idea. So we already did intersection, which means common or both, right? So what is the union all about? The union of events. What is that all about? Okay, so that's what we're gonna discuss right now. Anyone ever did union of events before?
Yes,
You
sir.
said events?
Union of events.
Not of events, but just union.
Union of a set. Yeah. Okay. The same concept. Same idea. So looking at union of events. So take this down for me. Union of events. All right, so the union of the events, capital E and F, is the set of all outcomes in E or F. So it's a set that is, it could be in both of them. Or both. So thus, the symbol that we use for intersection is not an upside down U, but it's a right side up U. So E, capital E, excuse me, union, that's like this, union F, right? Thus E union F represents the event that E occurs or F occurs or both occurs. All right. Okay, so let's look at some examples for union. So for union of events, let's say that we have the experiment. I say that the experiment is that you are rolling a two roll a fair die and observe the numbers facing up. Good. Let's say that that's your experiment. Okay, question to Sienna. What is going to be my sample space for this experiment? Hello? I didn't hear you. Go ahead, Sienna. What's going to be my sample space? I cannot hear her. So I guess I'll ask the other one. Caitlin, what do you think is going to be in my sample space?
5, 6.
Very good. 1, 2, 3, 4, 5, and 6. Because that's the numbers that are on the coin. Not coin, that's the numbers that are on the dice. 1, 2, 3, 4, 5, and 6. And let's say my event. So my event is E. And I'll say that's the event that how did I say up top? So let's say that we observe an even number. Let's say that's our event. So we've seen this event before. Go ahead, Jasmine.
I can answer.
Go ahead.
It's 2,
Uh-huh.
4,
Uh-huh.
6.
Very good. And let's say that my event F, let's say my event F, my new event, is that I observe a prime number. Now, who could do this one? I observe a prime number. Go ahead, Jasmine. Go ahead, Jasmine. I see your hand raised. Oh, that's probably from before. Okay, so let's see.
1, 3, and 5.
1, 3, and 5. Okay, very good. 1, 3, and 5. They are the only prime numbers that are part of S. Okay. 1, 3, and 5. Remember, prime numbers are numbers that only has two factors, one in itself. Okay, so this question is for an intersection of event E and event F. So, Miss Johnson, what is the intersection of event E and event F? Go ahead, Miss Johnson. What's the intersection of event E and event F?
There is none.
There is none?
No, sir.
Okay, so if we have, okay, I don't want to use this example. No, we're not looking at intersection. We're looking at the union, sorry. Looking at the union. That's not the intersection, of course. Intersection is empty. Okay, so the union I have to explain. Sierra, you want to try the union? Remember, for the union, it have to be an E, have to be an F, and have to be, or both of them.
And
So
none.
none. Wow. Deja, you
Or
want to?
3 and 6.
No, Deja, you want to try the union?
The union. Okay, so just be 1, 2, 3, 4, 5, 6. It has
Yes,
everything in it, right?
it has everything. Interestingly enough,
By the way, I think 2 is a prime number too.
observe a prime number. Yeah, 2 is prime. 2 is prime. Okay, good. So the union ends up being S. Okay, so what the union is in this case? So the union is, for those persons who do not know, the union is going to be, and the union is going to be, I think it'll be better if I change this example. So let me change this one to odd. Sorry for those who wrote that. I think it'll just be a better example for you to see. 1, 3, and 5. Yeah, good. And a prime now, and then the union is still. I don't want the union to be the good. Yeah, that's good. Perfect. This is good. This is perfect. So, all right. So change that to observe an odd number. All right. So the event E is going to be observe an odd number. So it's 1, 3, and 5. And event F, you observe a prime number. A prime number is going to be 1 is not prime, by the way. 1 is not prime. So prime numbers are only 2, 3, and 5. Good. So your union is going to be everything that is in E and everything that is inside F with no repeats. All right, so let me say it again. The union is everything that is inside E and everything that is inside F with no repeats. So let me just write that down. Union is everything in E and everything in F with no repeats. Okay, good. So with that in mind, anyone want to try? No? Okay.
2, 3, and
Go ahead, Caitlin.
1, 2, 3, and 5.
Very good. 1, 2, 3, and 5. So 1 is in E. So that's the first one that's gonna go. Right? The next number that could go is
3.
3, yeah. because 3 is an E,
5.
and 5, yeah, 3 and 5. And then after that, we gotta put 2 and what? We already have 3, and we already have 5. So we don't need to put them again. Okay? So
Alright,
yeah,
can we just leave that?
say it again.
So we just leave it like that.
You just leave it like that. So the answer is 1, 3, 5, and 2. But we like to write it, in order. So we're just gonna arrange it in order now. So 1, 2, 3, and 5. All right. So your answer is just basically everything in E and everything in F, but no repeating. All right. All right, so that's the union. So let's do another example.
We're gonna practice. We're gonna practice this.
Yeah, you know how we go. You know, we're gonna practice. For sure. All right, so let's say the experiment is that I didn't wanna, instead of using a fair die, let's say you're choosing numbers from 1 to 10, say. What's gonna be the sample space, Deshaun?
1, 2,
Uh-huh.
1, 2, 3, 4, 5,
Mm-hmm.
6, 7,
Mm-hmm.
8, 9, 10.
8, 9, and 10. Very good. Let's say my event E is I want multiples of 5. So Miss Johnson, what is my event E gonna consist of? If I want multiples of 5.
5 and 10.
Very good. 5 and 10. Okay, good. So my event E is gonna be 5 and 10. Because they are multiples of 5. 5 and 10. Good. Now let's say my event F. This one is for Sienna. Let's say my event F is I want multiples of 3. So what are my multiples of 3, Sienna?
3 and 6.
3 and 6. Very good. It's my event F. 3 and 6. Okay, so Miss Neely, I mean Rainisha Neely, what is my union of event E and F? What's gonna be in that? Rainisha Neely, are you here?
I try to figure out it. 1.
Okay. Why you say 1?
Excuse me.
One moment, Albany. Why you say 1, Miss Neely?
Because they're supposed to be the numbers that were aren't in E and F, right? Like 5 and 10, 3 and 6.
No, remember everything. Remember the union is everything in E and everything in F with no repeats. Okay.
Okay, sir. Thank you.
Okay. So what's gonna be in your union? Go ahead, Miss Neely. Finish it up. What's gonna be in your union?
10 and 6.
Okay, 10 and 6. What else? What else is gonna be in your union?
3 and 5.
3 and 5. Very good. So everything in E and everything in F. Okay, with no repeats. So your union is gonna be E union, and the symbol should be here somewhere. E union F. Go ahead, Albanic. You had a question?
My question was, it's a choosing numbers from 1 to 10.
Uh-huh.
So they would 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh yeah, 9. I forget 9. So multiples of 3 would include 9, eh? Thank you. You would have 9 in there. Okay, thank you much. Very good observation, Albanic. So that means that we can have what? 5 and 10. And what else? 3, 6, and 9. But like I said, we like to put them in order. So in order, what would it be, Rashan? We're arranging them in order.
3, 5, 6, 9, 10.
Very good. 3, 5, 6, 9, and 10. So it's our union. So E and not, and the union is U, not N, U. So E union F. Gonna be 5, 10, 3, 6, and 9. Everything in E and everything in F with no repeats. All right. Okay. So let's use another experiment or another example. I like this experiment. It's kind of flexible, so let's use it again. So in this experiment, we are choosing numbers from 1 to 10. Okay, so Miss Johnson, what's going to be in our sample space? Go ahead, Miss Johnson, what's going to be in our sample space?
1, 2, 3, 4, 5, 6, 7, 8, 9, and 10.
Very good. Nine and 10. Good. And let's say my event E is, let's say, oh, I should please put this in your experiment. It have to be at random, okay? At random. So that's a very important part of the experiment. Can someone explain why I must put at random? Why it have to be at random? Why you think we must?
Any number can come up.
Yeah, very good. And with experiments, we want it to be random. Why we want it to be random?
Maybe you show that you're not intentionally picking a number.
Exactly. Because we don't want to be intentional about picking a certain number. Because with an experiment, the idea is that you don't know what's gonna happen. So it have to be at random, okay? And at random means like you close your eyes and you pick it. So you're not looking, say, oh, I want 7 or I want 8. No, at random. Okay. You don't know which one you're gonna pick beforehand. Okay, that's what we mean by at random. All right, so okay, so let's say our event E is that we're looking at multiples of 4. All right, so Caitlin, give me the multiples of 4 from, or basically tell me what the event will be if we're looking for multiples of 4.
One, two, and four.
Say it again.
4 and 8.
4 and 8. Very good. 4 and 8. Okay. Next up, we want this our event E, and then we want event F. Say we want multiples of multiples of 2. So Sienna, what's going to be the multiples of 2? So it's going to be event F. Go ahead. I can't.
2,
Mm-hmm.
4, 6, 8, 10.
Very good. 2, 4, 6, 8, and 10. Okay, good. Miss Rashan, what's going to be my union of event E and F?
2, 4, 6, 8, 10.
Very good. That's it? The union of E and F? 2, 4, 6, 8. Yeah, she's right. That's true because E and F, 4 and 8 is a part of it. Very good. I like that. Very good. So the union, yes. So the union is going to be, remember, 4 and 8, and also everything that's also a part of F. So the union, we write that as E union F, and curly brackets. It's going to contain everything in E and everything in F. So 2, 4, 6, 8, and 10. Okay, good. Let's look at another experiment. So let's say the experiment that we have. is choosing at random letters from the word the Deshaun.
Yes, sir. You call me?
I using your name an example. Yeah,
Oh.
yeah. All right. Let's say so what's gonna be our sample space? So Jason, what you think our sample space is gonna be?
D,
Uh-huh.
E,
D E
S,
S
H,
H
A,
A
W, N.
W N. Very good. Okay, good. And let's say event E is that you observe we choose a vowel. So what's gonna be a part of our event E, Sierra?
ENA.
E and A, very good. Because those are only vowels, E and A. I'm gonna say our event F is that we choose a consonant. So what would be a part of our event F, Miss Johnson? Event F is that we choose a consonant.
D S H W
Very good.
N.
And N. So D, S, H, W, and N. Very good. Okay, so what's going to be, Caitlin, the union of events E and F?
D, S, H, A, W, N.
Say that again. Repeat that one more time. I missed it.
D, E, S, H, A, W.
Very good. Very good. Very good. So the whole word Deshaun again, because it includes everything. E and A and D, S, H, W, and N. I really like this name. It's a very good example, Deshaun.
I can see that.
Yeah, it's a very good example. So E union F. All right. So we did intersection of events. Albanic, do you remember what we mean by intersection of events? What does that mean?
Intersection of events.
Yeah, intersection.
Of all the outcomes common to E and
Okay. So with the intersection, we pick in those numbers are letters that are common, the same, okay, in both. But for union, we're looking at all of the letters or numbers, all of the elements that are both in E and in F with no repeats. Okay. All right, so that is intersection and union. Now we're going to look at a next section. Now all of this we haven't you notice we haven't defined probability yet, right? We haven't even defined probability yet. All we have looked at is sample space, events, outcomes, intersection of events, complement of event. We haven't defined what probability is yet. We haven't even given the definition of that or a formula for it yet. This is just getting you thinking about probability. Okay. I think this week we're gonna actually deal with the definition of probability. And all of the things that we've been looking at so far are gonna arise in that definition. Okay. Or at least a lot of those concepts. Okay, so the next thing that we're gonna look at is we'd call it mutually exclusive events. Okay, so that's the next section. We're gonna look at mutually exclusive events. So mutually exclusive events. So what do we mean when we say two events are mutually exclusive? All right. So here's what we mean. If E and F are events, then E and F are said to be disjoint. This is a key word. How is that capitalized? That disjoint. Or mutually exclusive if the intersection is empty. So if E intersect if E intersect F is empty. So what does that mean? Hence, they have no outcomes in common. So whenever you have two events that have no outcomes in common, all right, we say that these events are mutually exclusive. So let's visualize it. So if we were to visualize mutually exclusive events, so visualizing it will look something like this. So let's insert a box. Oopsies, sorry. Remember, they are disjoint, and hopefully you get understand why we call them disjoint, because they're separated. Okay, so if we look at this one, so we call this one event E. All right, we call this one so this is going to be event E. Let's move this out. And this is event F. Now, if you look carefully, there is no intersection. Okay, they are separated. We call these disjoint sets. All right. So they have nothing in common. If they had something in common, you know how we would have drawn them? We'd have drawn them like this. It would have been this set with that set, E and F. If they had something in common, all right, this would have been the intersection. But because they have nothing in common, we separate the two sets. Okay, so we'd say that event E and event F are mutually exclusive, right? They have no elements in common. Okay. So let's look at an example of mutually exclusive events. Now, the idea with mutually exclusive events is that note for mutually exclusive events, if two events are mutually exclusive, then this means that it is impossible for the two events to occur simultaneously, or we'd say at the same time. So if they are mutually exclusive, they cannot happen at the same time. Okay, so give me an event that cannot happen at the same time. or two events, sorry, that cannot happen at the same time. So example. No one will know examples. Two
I
events that.
guess the metal can attract and repel at the same time, or that's a weird one.
Say it again.
Like a metal would not be able, not a metal, a magnet would not be able to attract or repel at the same time. Attract and repel at the same time.
Okay. All right. All right. That's a good one. It's pretty deep. Okay.
I got one.
Go ahead. Yeah.
A coin, one single coin cannot go on heads and tails at the same time.
Perfect. That exactly. That's a perfect one. So, a coin. Okay. So, the event that you get a tail. Okay. So let's say, getting. So, a coin landing on heads and tails at the same time. That's impossible. Those two events are mutually exclusive. Either you land on head or you land on tails. Okay. A dice landing on an even and odd number at the same time. So if the dice can't land on an even and odd number at the same time. Because if it lands on an even number, then the even number cannot be odd. And if it lands on an odd number, that odd number cannot be even. Alright? So it's impossible for the coin to land on an even number and an odd number at the same time. So next thing is it's raining. It is raining. And there is not a cloud in the sky. Alright, that's impossible. If it's raining, there are clouds in the sky. Alright. So that's the thing. Alright, so those are examples. Any questions before we go on to do the exercises? Okay, so no questions. So let's go right ahead and do the examples or the exercises. Okay, so for the exercises,
Hey, before we do that, I have a question.
Go ahead.
Okay, it's unrelated, but seriously, can a magnet repel and attract at the same time, or it can't?
Not that I know of. I mean, if it's attracting, you mean two magnets, right?
I mean, like a magnet. Say you have a magnet, you have some iron powder or something.
Yeah.
Can it attract and repel at the same time?
I mean, technically, if we're dealing with different objects, so, you know, but two objects cannot repel and attract at the same time. So if you're dealing with binary, so if you have a magnet and an iron, they either attracting or they repelling. But if you have an iron, a cloth, and an iron, and sorry, an island filings, you know, obviously the iron is going to attract to, say, the iron filings, but to the cloth it's going to do nothing, right? So or say if you have a, and they could do that at the same time, right? Or say for example you have something that actually repels, say a north and south side of a pole. You have another magnet there, and you have some iron filings there. It depends on how much objects you're allowing, right? So, but if you're talking about two objects, no, it either attracts or repels. But if we're dealing with multiple objects, it could attract and repel. Yeah.
Wow.
Yeah. Okay, so yeah, so let's do some examples with these
You mean exercises?
exercises. Yes, exercises. Thank you for the correction. All right. Okay, so in each case, give the sample space so I want you to tell me what's the sample space. I want you to tell me what is the intersection and union of events. Okay. Okay, so number one. So let's say our experiment is to roll a fair coin. I say my event is a fair dice, sorry. I want you to tell me if my event E is that I observe an even number, and my event F is I observe a multiple of 3, tell me what is going to be my intersection and what's going to be my union. Okay, so intersection and union, this is number 1. Okay, let's say we have number 2. Let's say we're choosing letters at random from the word sharing. I want you to tell me what happens in my event if my event E is I observe a vowel. Event E. My event F is I observe a consonant. Tell me my intersection of events. Tell me my union of events. Number 3. Let's say I'm choosing at random. Numbers from 1 to 10. Tell me what will happen if my event is E is I want multiples of 4. My event F is on multiples of I'm gonna say multiples of 2. Say multiples of 5. What's gonna be my intersection of events? What's gonna be my union? Okay, so just those 3. Don't forget to make sure I put the sample space, intersection, and union of events. Okay, so you have 2 minutes on the clock, so I will set the timer now. Okay, and the timer has begun. All right, so that's time. Alright, so let's begin with the first one. For this one, for number one, Albernic, what is my sample space?
1,
Uh-huh.
2,
Uh-huh.
3,
Uh-huh.
4, 5, and 6.
And 6, very good. Altonic, what is my event E that I observe even numbers?
Okay. It is 3 and 6.
2, 4, and 6. Because you're looking for even numbers. Okay. The event F, Roshan, that I get a multiple of 3. What is that? Roshan, are you there? The event F, that I get a multiple of 3.
I see it.
Go ahead, Roshan. Okay. Go ahead, Albernic.
You call my name?
Yeah. Observe that I get a multiple of 3.
3,
3 and
3, and 6.
3 and 6. Very good. I think someone posted in the chat as well. Miss C, thank you. All right, good. Now we want the intersection. Caitlin, what's the intersection of E and F? I didn't hear that. Go ahead, Caitlin. Say it again. Go ahead, Caitlin. Say it again, please. What's the intersection of E and F? Okay, let me try Sienna. Sienna, what's the intersection of E and F?
2, 3, and 6.
The intersection? What's what they have in common? E and F. What does E and F have in common?
3 and 6.
E and F. So E only has 2, 4, and 6 in it. F has 3 and 6. So what
So
do
it's
they have?
just 6.
It's just 6. Very good. Good. Just 6. Okay, Miss Johnson. What's the union of E and F? Go ahead, Miss Johnson. What's the union of E and F? Okay, I guess she's not able. Go ahead.
2, 4, 6, 3.
Very good. So 2, 4, 6, 3. So 2, 3, 4. 2, 3, 4, and 6. Very good. Okay, good. Choosing letters at random from the word sharing. What's going to be my sample space? Roshan. Okay, I can't have from Rashan. Jasmine, what's gonna be my sample space? Choosing letters from the word sharing.
SHARNG.
RNG, very good. S H A R.
Let me do the whole number 2.
No. I just wanted you to give me a sample space. Thank you.
Oh.
Yeah. And G. Okay, Sierra. What's gonna be my event? E.
A and I.
Did I get a vowel? It's gonna be A and I. Very good. Sierra. Deja. Did I get a consonant?
S H
S
R N G.
H R N
And
and
G.
G. What's gonna be my intersection, Deja?
I just put an empty set.
Okay. What notation do you use for empty set?
You just use the curly bracket with your.
Okay. So because there's nothing in common in these two, we can we have to put the empty set. So the empty set is a circle with a slash. Okay. That's the empty set. A circle and a slash.
No.
Pardon?
So mine is the same thing, or that what I said was wrong.
That's not wrong. It's the same thing. So that's one way. That's one way we can write the empty set. Another way you can write the empty set is if you just do an open curly bracket with nothing inside. So this is also an empty set as well. So either one is an empty set.
You just put nothing.
No, you have to put something. Okay. All right. So the union, what's going to be a union of E and F? Caitlin, what's going to be the union of E and F?
SHA.
Can you repeat yourself? You stopped in the middle of saying it.
Share it. SHG.
Okay, very good. SHARING. Very good. Because it have to contain everything. So SHARING. Very good. Okay, so this one is for Miss Neely, Rainisha Neely. I want the sample space for number 3. Choosing numbers at random from 1 to 10. What's going to be my sample space? Hello, Rainisha Neely, are you there?
Hello, is it 2, 4, 6, 8, 10?
Well, we want numbers from 1 to 10. So
1, 2, 3, 4, 5, 6, 7, 8, 9.
And 10. Very good. So the sample space will contain all of them. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Good. Miss C, what's going to be my event? Multiples of 2. Miss Tasha, what's going to be my event? Multiples of 2. Okay. Okay, I guess she's not able to speak. Go ahead, Dylan. Multiples of 2.
2, 4, 6, 8, and 10.
2, 4, 6, 8, and 10. Very good. And then F, Deshaun, multiples of 5.
5 and 10.
Very good, 5 and 10. What's going to be the intersection, Dylan? Dylan, what's going to be the intersection of E and F?
So it's just 10.
Just 10, because 10 is common in both of these sets. All right, just 10. And Rashawn, what's going to be the union of E and F? Well, you can't have from Rashawn, so Sienna, what's going to be the union of E and F?
2, 4, 5, 6, and 8.
And one more.
10.
And 10, very good. 2, 4, 5, 6, 8, and 10. Okay, so make sure you have these down. Anyone got 3 out of 3? 2 out of 3?
3 to 3. 3 out of 3.
3 out of 3.
3 out of 3. Okay. All right. That's excellent. Very good. Excellent. All right, so let's do another example. Well, exercise before we close it up for math. So, all right. So write MA if the events are mutually exclusive and write NA if the events are not mutually exclusive. So if the events are mutually exclusive, that means that they cannot happen at the same time. It's impossible for them to happen at the same time. If they are not mutually exclusive, that means that they can happen at the same time. So NA if they are not mutually exclusive, and MA if they are mutually exclusive. Okay. So being a woman and being pregnant, so at the end you write NA or MA. Number 2, winning and losing a game. Number 3, turning right and turning left. Eating a sandwich and sitting on a chair. Running forward and backward. Reading a book and listening. Okay, good. So with this one, right, MA, if the events are mutually exclusive, that means that they cannot happen at the same time. Right, NA, if the events are not mutually exclusive, that means that they can happen at the same time. So you have 2 minutes, and then we can Do them together. And the timer has begun. So being a woman and being pregnant, winning and losing a game, turning right and turning left at the same time, eating a sandwich and sitting on a chair, running forward and backwards at the same time, reading a book and smiling, driving a car and walking on the streets, getting a massage and sleeping. Mutually exclusive or not mutually exclusive. Remember, mutually exclusive means that they cannot happen at the same time, and not mutually exclusive means that they can happen at the same time. All right, so that's us. Okay. All right, let's start with Caitlin. Being a woman and being pregnant, NA or MA?
NA.
NA, very good, because it's not mutually exclusive. These two things can happen at the same time. Winning and losing a game, Sienna, MA or NA?
MA.
MA, very good. All right, Miss Johnson. Turning right and turning left at the same time, MA or NA?
MA.
MA, very good. Mutually exclusive. Eating a sandwich and sitting on a chair, Jasmine, MA or NA? Where's Jasmine? Jasmine, eating a sandwich
NA.
and... Okay, you want to both? Yes, NA. Okay. All right. Running forward and running backwards at the same time, Sierra, MA or NA?
MA.
MA, very good. Can't do that. Reading a book and smiling, Albernique. Reading a book and smiling, NA, very good. You could do that at the same time. Rashan, are you there? Oh, we lost Rashan. Okay. Deshaun, driving a car and walking on the streets.
MA.
MA, very good. And Deja, Getting a massage and sleeping.
NA.
NA. Very good. Good. So any 8 out of 8, 7 out of 8.
8 out of 8.
8 out of 8. Okay. All right.
8 out of 8.
8 out of 8. All right.
7 out of 8.
7 out of 8. All right. All right. That's excellent. So which one did confuse you? I like that. I think that's Dylan who said 7 out of 8. Okay. All right. So that's the end of math. We're past you, right? It's 8:07. So we have English to do, and then I'll be out of your way. Look at that. So remember, for the math, you want to take a picture of your notes and send it to me right after class. I put my number in the chat. My number is 426. Where is it? 426-8891. So take a picture of your notes and send it to me right after class. Not tomorrow, but right after class. All right. Okay. Okay. So let me take a picture of these and put them in our notes. So some people already sending me the notes already. That's good. The rest of you, make sure you send them before the night is out. Okay. All right, so let's move on to English. All right, so we're gonna save this as sample space on events. And events part 4. And that one we did intersection, union, and what else? Mutually exclusive events. So we covered a mouthful today. All right, so let's move on to English. The last thing we was doing in English is sentence combining. So we're gonna continue with that tonight. So take down these notes for me as well. Today is Monday. So today is Monday, the 8th of the 8th of August, 2022. The subject is mathematics. The topic is
English language.
oh yes, English language. I so distracted in my mind thinking about something. English language. Thank you. Um, um,
Topic, sentence, combining, continued.
yeah, sentence combine and continue. Thank you. Thank you, teacher. Uh, continued. All right. All right. Okay. So when we did sentence combining last time, um, we look at sentence combining when you combine an object, right? When we have a compound subject, and when we have it with a verb. All right. Okay. So today we're gonna actually put them into practice, actually doing some little examples. I mean, even though we did it last time, we're going to extend that idea. Nothing, I don't think it's gonna be hard for us to do. All right. It's not difficult. It should be simple. But anyone can remember why we say that sentence combining is a good thing to do? Anyone can remember why is sentence combining a good thing to do? Why don't we just leave the two sentences just like that? Why is it a good idea to combine them? Anyone?
To have sentences of different lengths,
Like,
a variety of sentences.
yeah, so that we can have sentences of various lengths. Okay. There's also another reason, and that is sometimes what you say in the first sentence is essentially what you said in the second sentence, you know? Like, so they're very close to each other. And so if you have something like that, then that means that they basically saying the same thing. So why don't you just combine them? Okay. That's what we basically looked at. If the two things have the same central idea, right? Then it's probably a good idea to combine them, unless you don't want to combine them because you're trying to, make a certain effect, trying to give a certain effect on um, on your essay. Maybe that's probably why you don't combine them. But in general, we try to combine them, right? And so we can have a compound subject, a compound verb, or a compound object. So let's look at these examples. So some more examples on sentence combining. Hello? Can you hear me?
Yes, sir.
Yes, sir.
Oh, so you wasn't hearing me before.
You
No,
was
sir.
muted for a little bit.
Oh, okay, that's why. Okay, so I was talking all that while. Um, yes, Deja, how can we combine these two sentences together?
We could use a conjunction.
Which one? Which you want to use? Help me out.
We could say we could use and.
And okay, so you want to say my class went to the amusement park, and we also went to the zoo.
I guess so.
Okay, so maybe we can. My class went to the zoo. As well as to the zoo. My class went to the amusement park as well as to the zoo. Or and to the zoo. I think and feels better. My class went to the amusement park and to the zoo. Oh, perfect. Alright, so that's a combined sentence. My class went to the amusement park. We also went to the zoo. Alright, good. So let's look at this next one. This one is for Sierra. So this is uncombined. So at the amusement park, the carousel played music. It also rang bells. And you know, just so you can get an understanding what I mean by carousal, let me show you what I'm talking about. So anyone have ever ridden in this before when you was a child?
That's like a merry-go-round.
A merry-go-round, yeah. Anyone ever went on these before?
Yes, sir.
Okay. No, sir? Someone said no, sir?
Nope, I never went on them.
You never went on them? Where was your childhood? Where's your childhood, man? Oh my, you had no childhood, man. Well, at least, how old is you? How old are you?
I'm 16.
Okay, you still have a chance. You still have a chance, though. Your childhood ain't gone yet. You still have a chance.
No, still got it. Still got it.
Still got it, yeah. I just put in your leg. But yeah, I remember going on that. I was so anxious to go on it, you know. When you're a child, you want to experience, you know. And boy, did they make a lot of money from us going on those little merry-go-rounds. Boy, you can imagine.
Money?
What? Boy, you can imagine and those things didn't even take long. You know, but it was an experience, unforgettable. Yeah. Okay, so next up is okay, so at the amusement park, the carousel played music. It also rang bells. So how could we combine these two sentences together?
At the amusement. Okay. At the amusement park, the carousel played music and it also rang bells.
And rang bells. Right?
Yeah.
So we don't need to put and also.
Yeah, I was just about to say drop the also.
Yeah. Yeah. Because the idea is we're trying to shorten it too. So at the amusement park, the carousel played music. and ring bells. Okay. Now, if you want to be sophisticated, a little interesting, we can say while it simultaneously rang bells. That's another twist on it. So at the amusement park, the crowds played music while it simultaneously rang bells. And simultaneously, we learned that from last class is at the same time, right? At the same time. All right. Okay, so let's look at another one. Bum, ba-dum, ba-dum, bum. So let's look at uncombined. So the carousel was too mild for Deja. The Ferris wheel was too mild for Deja. So what could we say if we would combine them? Dylan, how could we combine them? All right, Deshaun, how would we combine them?
So,
Say it again, how would you combine them?
oh, you see, because I didn't have my stuff was freaking out. Sorry about that.
Go ahead. How do we combine them?
You could combine them with and.
So give me an example of the sentence.
Like the carousel was too mild for Deja. Well, hold on. Or you can say as well as the Ferris wheel, I guess.
That's
You say
true.
that.
But let's combine the object. So what I mean is we can say
Oh, the carousel and the Ferris wheel was too mild for Deja.
exactly because it's saying the same thing. So yeah. The carousel and the Ferris wheel was too mild for Deja. So uncombined, we can say At lunch, we ate sandwiches. We ate apples for lunch. We also ate raisins. So how can we combine these such that we can have a sensible sentence? Go ahead, Deja.
Oh boy. Okay, so I said at lunch we ate sandwiches.
Mm-hmm.
Comma apples
Mm-hmm.
and raisins. I didn't want to use that again.
Mm-hmm. That's
I'm
fine.
blank right now.
That's fine. It's a good shortened sentence, right? I mean this is like a run out. At lunch, we ate sandwiches. We ate apples for lunch. We also ate raisins. Like, I mean, come on, like put them in one sentence, you know? So definitely. I think I need to scroll down for you all because some of you still writing. Okay, so let's look at another one, uncombined. Everyone thanked our chaperones. Everyone asked them to come back next year. So Sierra, how would we combine this?
Okay, everyone thanked our chaperones and asked them to come back next year.
Very good. All right, so everyone thanked our chaperones and asked them to come back next year. All right. Okay, I think we get it now. I think we get the picture. So we can stop here. Make sure that you send me the class notes for today, and I'll see you on tomorrow at 6 o'clock so we can start it all over again. If you need to stay to finish right down, that's fine. But if you're done, you can leave. Have a wonderful night, everyone, and take care.
Bye.
Good night.
All right.
Good night.
Good night.